Hello and welcome back to this tutorial. So we are almost halfway to our data preprocessing phase. We learned how to import the library and import a dataset already. Also, we have learned how to take care of the missing data. And today we are going to learn how to encode categorical data. So the first thing that we are going to do is that we are going to explain why we need to do this. So I'm going to open my dataset. And in this dataset, we can see that we have two categorical variables. We have the country variable and then the purchase variable here. These two variables are categorical variables because simply they contain categories. Here the country contains three categories, such as France, Spain, and Germany. And the purchase variable contains two categories, such as yes and no. That is why they called categorical variables. And now you can guess that since machine learning models are based on mathematical equations, you can intuitively understand that it would cause some problem if we keep the text here and the categorical variables in the equations, because we would only want the numbers in the equations. So that's why we need to encode the categorical variables. That is to encode the text that we have here into the numbers. Okay, so in this tutorial, we are going to encode these two variables, country and purchase. So let's get started. As usual, we are going to import the library that will do the job for us. And this library is going to be actually the same library as we use to take care of missing data, is the scikit-learn preprocessing libraries. So let's just copy and paste here. However, we don't want to use the imputer here, so we just remove. We are going to import something else, which is the label encoder. Alright, so label encoder is a class from the scikit-learn preprocessing library. So exactly as we did when we took care of missing data here, we need to create the first object of the label and go to the class. Okay, so I'm going to call this object as label encoder. Okay, so since we were first going to take care of the country categorical variable here, I'm going to call label encoder underscore x equal, and then what I'm simply going to do is I'm going to call the label encoder class label encoder. So we simply need to do this. We simply need to create an object of the label encoder class, and then we are going to use this object on this column country here, which is our categorical variables. Okay, so to apply the label encoder on our column, we will type label encoder x. That is our object. Then we are going to take a method of the label and go to the class, which is dot fit transform. And we are going to apply this method on x, but not the whole matrix x. We just want to the first column. And I'm going to let you guess what to put next. We need to put the index of the first column, and we know that the index on Python starts at 0, so the index of the country column is 0. So here we are going to put brackets. We want the whole column, so here we put colon and then comma 0. Okay, so what we need to understand here is that by typing this line of code, we fitted this label encoder for x object to the first column country of our matrix X. And all this returns the first column country of the matrix X encoded. So that means that if I select this and execute, you can see that the output contains the 10 values of the first column of our matrix X, but this time is encoded. We no longer have the countries written in text. We have the encoded values of the countries. So now what we need to do is to take the first column here of the matrix X by putting here to here, so that the first column contains matrix X becomes these arrays of encoded values of the countries. Because as you can see, if I get X right in here, sorry, we can close here, so we can type X in here, we can see that the first column contains the countries in text France, Spain, and Germany. And now if I select this line and execute and type again in console. And now the first column of the X matrix has the encoded values. We can see that the France is 0, Spain is 2, and Germany is 1. Okay, so by doing this, we encoded the country column. However, do you suspect any problem that could happen? I will let you think for 10 seconds of what problem could happen here, and I will tell you what this is. Okay, so the problem is still the same. Machine learning models are based on the equation, and that's good that we replace the text by the numbers, so that we can include the numbers in the equations. However, since 1 is greater than 0 and 2 is greater than 1, the equation in the model will think that Spain has a higher value than Germany and French, and Germany has a higher value than French. And that's not the case. These are actually 3 categories, and there is no relational order between these 3. We cannot compare France, Spain, and Germany by saying that Spain is greater than Germany or Germany is greater than French. This wouldn't make any sense. If we had, for example, the variable size with the size like small, medium, and large, then yes, we could express orders between the values of this variable because the large is greater than medium and medium is greater than small. In here, it doesn't make any sense. So we have to prevent the machine learning equations from thinking that Germany is greater than France and Spain is greater than Germany. And to prevent this, we are going to use what we are called the dummy variables. That means that instead of having 1 column here, we are going to have 3 columns. We are going to have a number of columns equal to the number of categories. So since we have the 3 categories here, such as France, Spain, and Germany, we are going to have 3 columns. Each of these 3 columns will correspond to 1 country. We are going to have French column, the Spain column, and Germany column. And each column there is going to be either 1 or 0. So for example, if we are in the French column, it's going to be 1 if the country is French, and 0 if the country is not French. So let's do this. So let's create those dummy variables. To create those dummy variables, we are going to use another class, because the label encoder only encodes the values without bothering if there is order or not. So we are going to use another class here, which is oneHotEncoder. Okay, as usual, we are going to create one hotEncoder object. So I'm going to call it oneHotEncoder equal. So that's the object. And here we are going to call the class oneHotEncoder parenthesis. And now let's inspect this class. We have some information about the oneHotEncoder class. Let's look at the parameters to see where we have to input. Here's the first parameter is end values. So that the number of values per features, we don't really care about that basically. But an important parameter is the second one, categorical features, that specify what features are treated as categorical. So basically what this means is that we need to specify the index of the column, that is the column of the categorical variable, which is the categorical, and it has an index number 0. So here we are going to input categorical features equal to bracket 0. Alright, so that way we specify which column we want to oneHotEncode categories. Okay, so now our object is ready here. Now we need to feed it to our matrix X. So let's do this. X equal, because we want to transform X, then we use object oneHotEncoder dot feed transform X. And we don't have to only take the first column of X, because he was specified to 0 index, so that's fine. And then we just need to add dot to array parenthesis. Okay, so that will oneHotEncoder variable X, and you will see exactly what it's going to do. Okay, so now we must not forget to reselect and execute this line, because we import a new library which is the oneHotEncoder, and then we want to execute these 2 lines. Alright, and now let's have a look at X by typing X here. Okay, but maybe you want to check the variable X using this. And also we want to open our dataset too. Okay, so as I told you, the first column here, country, was replaced by 3 columns. And then we still have our 2 columns, which is the age and the salary. So what I was explaining, that this first column here corresponds to French, the second column here corresponds to Germany, and this third column here corresponds to Spain. So here, for example, let's take the first line. We know that the first line that has index 0 is the country French, and since the first observation is French, then that means that the first column here is going to be 1, because this corresponds to French column. Then since the second column is Germany, then it's going to be a 0 here, because the first observation is French and not Germany. And the same for Spain. The third column here is Spain, and it's 0 because the first observation is French and not Spain. And that is how you encode the dummy variables, by making sure that the machine learning models don't attribute in order into the categorical variables. Okay, so let's close this. And now let's take care of the second variable, which is the purchase one. And now we can be relieved. We don't have to use one hot encoder. We will just need to use label encoder, because since this is the dependent variable, the machine learning model will know that it's a category, then that there is no order between the two. So for the purchase column here, which is the dependent variable, we are only going to use label encoder, and that's what we are going to do. So we are going to do it very quickly. I'm just going to copy this and paste here. So we're going to call it labeling code Y. We cannot use this object label encode X because this was fitted to the X column here. So we want to change all the X into Y. So we created our objects of the label encoder class that will be fitted to Y and that will transform Y into encoded variable vector. So let's select these 2 lines and execute it. Oops, I'm sorry, I forgot to change this one. Let's run again. Here it is. Now let's have a look at Y. Now if we look at the vector Y, it's encoded, and the label encoder class attribute is 0 to no and 1 to yes. Okay, perfect. So congratulations, now you know how to encode a categorical variable in Python. If you're still not very comfortable with the dummy variable concept, then don't worry, because there will be another explanation in the multiple linear regression section, where I will explain in much more detail by talking about the dummy variable trap. So that was the first explanation, but the intuition is maybe going to get better built later in this course and multiple linear regression section. I know this was quite a long tutorial, but we almost did the most difficult part. We are approaching soon the fun and exciting part about making models, so we are almost there. Hang on for 1 or 2 more tutorials, and this is going to get very exciting. Thank you for watching this tutorial, and I look forward to seeing you in the next tutorial. Enjoy machine learning and have a good day. See you.